Hi, this is the different analytical methods for qualitative and quantitative analysis of fluorescent versus non-fluorescent consumer alcohols by
Alfonso Sierra,
Jesus Castaneda,
David Young,
and Stephen Montoya.
Raman spectroscopy, named after Indian physicist Sir C. V. Raman, is a spectroscopic technique used to observe vibrational, rotational, and other low-frequency modes in a system. It is commonly used in chemistry to provide a basic fingerprint of a molecule which can then be identified. It relies on inelastic scattering or Raman scattering of monochromatic light, usually from a laser in the visible near-infrared or near-ultraviolet range. Usually when light is scattered from a molecule, light is scattered elastically and so both energy and frequency are conserved. But about 1 in 10 million photons are scattered inelastically, where the frequency of scattered light is either higher or lower in energy than the incident photon frequency. The transitions that are the most important for scientists using Raman spectroscopy is molecular vibrations. The Raman shift is the difference between the energy of the incident photon and the Raman scattered photon, which is then plotted versus intensity to give a Raman spectrum.
Raman is efficient as it is very fast at measuring Raman spectrum. This allows us to measure multiple sets of data and average it out. The sample preparation is also very simple. The data that is collected is processed and plotted as wave number versus intensity. For ethanol, we are able to see multiple peaks, but we use the intense peak at 888 wave numbers for analysis of ethanol concentration. Due to Beer's law, the peak will increase in intensity proportionally with increased ethanol concentration, which allows us to create a calibration curve to calculate the amount of ethanol in our alcoholic sample.
GCMs, otherwise known as gas chromatography mass spectroscopy, is a common analytical method. To initiate the GCMS process, a syringe with the desired compound is placed in the GC column, also known as the stationary phase. The column is then heated, which will cause the compounds to move and will make the sample vaporize and mix with the gas mobile phase. The larger molecules are caught by the stationary phase. As the mobile phase moves through the column, the components are then separated based on their volatility and affinity of each phase. The compounds elute at different rates and are then analyzed by the mass spectrometer. The third phase of GCMS involves ionization of the molecule with the mass spectrometer. The molecule from the GC is hit with electrons, causing it to fragment into molecular ions. These fragments are then accelerated through the detector and the mass analyzer by a differential voltage. The ions are now ready to be concentrated into a beam so that only positive ions hit the detector. A typical GCMS run lasts about 90 minutes, in which the mass spectrometer scans the mass range of interest every 3 seconds.
To first interpret the GCMS data, one must understand that the x-axis on the chromatogram is the retention time, which demonstrates the amount of time it takes for the analytes to pass through the column and reach the mass spectrometer detector. The peaks along this axis correspond to the time at which each of the components reach the detector. The type of column during the analysis, along with other factors such as flow rate, injection temperature, and oven temperature, can influence the retention time. To conserve consistency, it is recommended to maintain the same parameters to maximize accurate readings. The y-axis corresponds to the area of the peaks and it reflects the amount of a specific analyte that is present. When looking at the chromatogram, the area will be based on the count by the mass spectrometer at the retention point.
Different analytical methods employed by scientists to analyze ethanol concentration can range from more common methods like GCMS and Raman to less common methods like HPLC or FTIR. The primary method employed is GCMS due to its easy sample preparation, the ability to measure most sample solutions, and the low cost of the instrument. The drawbacks of GCMS is that the data is hard to reproduce from one run to the next, and that each run can take from 30 to 90 minutes. Raman spectroscopy, as a method of quantization of ethanol concentration, is a useful tool employed by scientists due to easy sample preparation and really fast measurements, which allow for more accurate average data with better signal-to-noise ratio. This allows Raman data to be more easily reproduced, as well as have greater precision and accuracy. The issues with Raman are that the instrument and system setup costs a lot of money, and the spectra is easily drowned out by fluorescence, which makes complicated samples hard to measure accurate data. So, overall, Raman is a much better method of analysis for non-fluorescent hard alcohols that have matrices that are less complicated. The accuracy and precision for such samples is higher than GCMS, and since it is also faster and easier to set up, it is the most efficient method of analysis for non-complicated mixtures. GCMS is the most widely used technique due to its ability to measure almost any alcoholic beverage's ethanol concentration, and even for non-fluorescent alcoholic beverages, it still has a very high R-squared value, so it is very accurate. For fluorescent alcoholic mixtures, GCMS is the cheapest and most accurate technique. So, in conclusion, we found that Raman is an increasingly more common method of quantization of ethanol concentration in consumer alcoholic beverages. Raman is great for non-fluorescent beverages, but becomes more difficult to use as a method when beverages are complicated fluorescent mixtures. GCMS is the most common method due to its ability to measure nearly any alcoholic sample with relative ease and very high precision. Raman is better for non-fluorescent compounds due to very fast measurements and easy data analysis, whereas GCMS is better for pretty much anything else. So, thank you for watching our video and have a great one.